Hello everyone. Welcome to Allied's YouTube channel. Here we embark on a journey to explore groundbreaking advancements in accessibility and technology. In this week's event, we will hear from Tim Arborealis from MTM. In this talk, Tim dives into the unique challenges of making STEM books accessible, from navigating complex math expressions in Braille to the latest digital tools used in talking books. Learn about the advancements, ongoing challenges, and the intriguing process of technology to speak math. Without any further ado, let me present to you the event. So, hello everyone. Thank you so much for joining us today. I am Farheen Zubair, the Allied Project Manager and your host for today. Today, let us start by welcoming our special guest speaker for today, Tim Arborealis. He is the production manager for Talking Books at the Swedish Agency for Accessible Media, MTM. So I would also like to take a moment to introduce to you our founder, Dr. Mona Mankara, who's not present with us today. She's traveling for work. But we have our co-director, Dr. Sandra Scheffelbein, who's joined us online. And as you all know, that we make all of our events accessible with an ASL interpreter. So thank you, Valerie, for assisting us today. Before I let Tim speak, I have to tell you a little about what Tim does. As I already mentioned, Tim Arborealis is a production manager for Talking Books at the Swedish Agency for Accessible Media, MTM. With a background in astrophysics, their primary focus is making books with STEM content accessible. MTM is working for everyone's right to read on their own terms: science, technology, engineering, and mathematics. STEM books are especially challenging to make accessible. Users have different needs, such as hearing math spoken aloud or reading complex expressions in Braille. New digital tools make it possible for users to access STEM books in a way that works for them. Tim will be talking about cutting edge technology on the book production front, what challenges remain, and some lessons learned. And he will also be talking about the lessons learned from teaching a robo how to speak math. Very interesting. Without any further delay, Tim, I would like to pass on the floor to you.
And my primary focus is STEM. My background is in astrophysics, and I used to work at a science center explaining science and experiments to students and the general public. And now I work with trying to make books on STEM as accessible as possible. So in this presentation, I am going to talk about this, and at the end, you will know the answer to the question of accessible STEM books. Are we there yet? So hang on to your seats. And in my slideshow, I will share a few images. I will describe them when it's relevant, but most of them are decorative. And if at any point there is something that you don't understand, please feel free to interrupt me, and I would love to answer any questions. And there will also be time for discussion and more in-depth questions afterwards. So a bit of legal background. In the European Union, we have something called the European Accessibility Act, which is coming into force the 28th June next year. And this act says that all e-books need to be made accessible, and all the European Union countries have to have this in their country's legislations. And this applies to all books that are to be distributed or sold within the European Union. So if, for example, an American publisher wants to sell their books in Europe, this law will apply to them as well. And at MTM, we will be the control institution of this in Sweden. So it will both be our job to see that this law is followed, and we will continue to step up and provide accessible books when the market fails to do so. So we will both control and try to lead by example. So I'm going to talk a bit about our users. Anyone in Sweden who has a print disability has access to our library of digital books. And a print disability could be caused by a number of different things. For example, it could be because you're blind, you have low vision, you have dyslexia, you're neurodivergent, and this isn't an exhaustive list. There could be other things that prevent you from reading an ordinary physical printed book, possibly disabilities that we aren't aware of yet. But if you fall into any of these categories, you have access to our services in Sweden. And if you're a STEM student with a print disability, what do you then need in order to access your books? Well, as those of you who have been studying within the field of STEM are probably aware, math is the common language for all STEM subjects. And math is a special kind of language. It's not like ordinary language that if you would read a novel and a word is misspelled, you could probably still understand the meaning of that sentence. But in math, if you change one single little detail, if a plus happens to be turned into a minus, for example, that could distort the entire meaning of the expression. And this means that it is very important that the math is correct, because otherwise you might learn something that is wrong because you're just learning this subject and maybe you can't spot that it's an error. And this is a challenge when converting from one format into another, for example, from a physical book into a digital one. And I will expand upon that later. Another essential thing is for the math to be accessible. And here users have different needs. Some benefit from hearing the math spoken aloud. Others might need to have it accessible in Braille. And still others might benefit from having the expressions highlighted while they're spoken so that they're visually synchronized with the audio. And then another essential feature would be to navigate inside mathematical expressions so that you can hear them spoken or read them in Braille one piece at a time. For example, many of my course books in physics had equations that would span half a page. And imagine hearing that spoken from beginning to end without a pause anywhere. There's no way you could keep all of that in your head at the same time. So you need to be able to go into it, maybe check just the denominator or the numerator and examine it piece by piece and gradually build up your impression of the entire expression. But it doesn't help if you have correct math and accessible math, but you don't get your course books until the course is over. STEM books are among the most challenging books that we make accessible. It takes a lot of time. Production time can be up to half a year. And then that means you would have to wait for a long, long time before you actually get access to your book. And the bulk of that time is for human narration. So for someone to speak the audio and record it for the book. And what about text to speech then? Most of our other course books that we make for university studies are made using text to speech. That is a computer generated voice that reads the text and we put it as an audio layer on top of it. So in the end, you would get a book with text that highlights synchronized with the speech, and it's spoken by a robot, more or less. But there is a problem when it comes to STEM. Our synthetic voices don't know how to parse math. If they come across an expression that's more complicated than, say, 1 + 1 = 2, they would just go silent, as if they have performance anxiety. And the math is not spoken at all. So therefore, we must have a human read this aloud. But I am working to change this by teaching these voices how to speak math. And I'm going to talk more about that now. But first, we need to consider, why is it so challenging to make math accessible? I'm going to read you an example of an equation here. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. And those of you that can see the expression probably had no trouble following along. But if you can't see the expression, you might have noticed that what I just said was ambiguous. For example, it wasn't quite clear where the square root ended and where the fraction began. So it is very important for the math to be spoken precisely for it to be fully accessible. And one way to help a synthetic voice do that is to use so-called MathML markup. And MathML is a subset of HTML, which is a web standard. For example, all of Wikipedia has its math marked up using MathML. And what I'm showing here is the MathML markup of the expression that I just read out. And for those of you who can't see it, let me just tell you that there's a lot of details in here. Basically, every single sign, digit, and number has its own tag to mark it up. And this means that there is a lot of information that you can put in here. MathML is a powerful tool to convey meaning. So in here is the information of where that square root ends and where the fraction begins. But this also means, with so many details, that a lot can go wrong in the markup process. So it's very important to be careful when doing the markup to get it right. But once you do that and have your meaning in there, you can be very precise. Another example of what I mean by meaning is this. A left parenthesis, x minus 1 right parenthesis. This could be interpreted in at least two different ways. Either it could be a multiplication, a times x minus 1, or it could be a function, a of x minus 1. And which one it is to be is determined by the context in which the expression appears. And once you know that context, you can put that information into the MathML. And then when you have your good MathML markup, you can use a tool called MathCat in order for the screen reader to access it. And MathCat is a plug-in tool for screen readers. It stands for Math Capable Assistive Technology. And what MathCat does is that it turns MathML into so-called SSML, which stands for Speech Synthesis Markup Language. And this, in turn, gives instructions to a text-to-speech engine so that it tells a synthetic voice what to say. And MathCat also has support for navigation, like I explained before, you can go into a mathematical expression and examine it in detail. It is highly customizable. For example, you can decide how much in detail you want the math spoken, or if you want more of an overview. It also outputs Braille for your digital Braille display, and LaTeX if that's your preferred manner of reading math. And a great thing about MathCat is that it is free and open source. It is developed by one of your countrymen, in fact. He's called Neil Seufer, and he's doing this for free. And what we have done as governmental agencies is that when it is an open source project, we are allowed to contribute to it. So we have translated MathCat into the Nordic languages. Swedish and Finnish is already out there, and Norwegian, Danish, and Icelandic are also coming along, hopefully later this year. And I'm going to demonstrate to you how MathCat works with a screen reader on a Wikipedia page. So here's a pre-recorded video where first we will hear what the screen reader does without MathCat engaged. And then when you plug MathCat in, you will hear if it makes a difference. So let's get this going.
Without MathCat. Definition. Let be a real valued function defined on. We say that tends to as approaches, or that the limit of as approaches is if for any there exists such that for all implies that. We write this symbolically as or as. With MathCat. Definition. Let f be a real valued function defined on E is a subset of the real numbers. We say that f of x tends to L as x approaches x sub 0, or that the limit of f of x as x approaches x sub 0 is L if, for any epsilon is greater than 0, there exists delta is greater than 0, such that for all x is a member of E, 0 is less than the absolute value of x minus x sub 0 is less than delta, implies that the absolute value of f of x minus L is less than epsilon. We write this symbolically as f of x right arrow L is x right arrow x sub 0, or as the limit as x approaches x sub 0 of f of x is equal to L.
So, as you heard, that made quite a lot of difference. Without MathCat, the screen reader went silent when it came across a mathematical expression. But with MathCat engaged, you could hear it.
Without MathCat.
But there are other things that need to be made accessible than just mathematical expressions in STEM. Most STEM books are chock full of graphs and diagrams. And there are some things that need to be done for these to be accessible. For example, it's important that the color coding is right and that they have sufficient contrast so that they're accessible to, for example, the colorblind. And then for people who are unable to see the graphs and diagrams entirely, it's essential that image descriptions are provided that convey the entire meaning of them, preferably put in alt text so that you can access it with your screen reader. And then you could also benefit from having tactile images that you can touch and examine with your fingers. For example, on swell paper that you get on the side, but also new technology is coming along with multi-line digital braille displays that can rearrange according to whatever image you're looking at, if it's in the right format, and you can zoom in and examine it. But this is a very new technology that's not all the way available on the market quite yet. So let's begin to recap a bit. To make accessible STEM books, here's a checklist. To begin with, make sure you choose a format that is compatible with assistive technology, such as EPUB, HTML, as opposed to, for example, PDF. Use MathML to mark up mathematics. Provide image descriptions for your graphs and diagrams. And then, as an option for your digital accessible STEM book, you could choose to provide a built-in audio layer. And this will make the book accessible also to people who are not used to using screen readers. And this is exactly what we're working on developing on MTM, and that I'm going to show you a demonstration of in a minute. So what we have done is that we've taken MathCat and built that into our production system to teach our TTS voices how to speak math. And now I'm going to show you our prototype. Let's see. Here it is.
Given a general quadratic equation of the form. Given a general quadratic equation of the form. ax squared plus bx plus c is equal to 0. Whose discriminant b squared minus for ac is positive, representing an unknown, with a, b and c representing constants, and with a is not equal to 0, the quadratic formula is x is equal to the fraction with numerator negative b plus or minus the square root of b squared minus for ac, end root, and denominator 2a, end fraction, where the plus.
How are you doing, Valerie? Did you get all that? Awesome, I'm impressed. So yeah, back to my presentation. What you just heard was, and saw potentially, was an EPUB book with an audio layer as a media overlay recorded with synthetic speech. So this was not a human narration, but a robot speaking it. And this is pretty new, and we still have some details that we need to iron out before these books will be available for distribution to our users. But we hope to be all the way there for fall term next year. And one thing we need to make sure we have in place then is a tool to make sure that the MathML is of high quality, because otherwise, as I explained, the TTS voice can't do its job properly. And if you want to go ahead and publish STEM in an accessible way, there are tons of resources out there. You are not alone in this endeavor. So this is a list of some of them that we have found useful. First of all, it is a good idea to use web standards. So, because if you do, that increases the chance for your book or your article to work regardless of reading platform. And take a look at the W3C specifications for HTML, EPUB, and MathML. There is the DAISY Publishing Knowledge Base, which is a collection of resources on accessibility. For example, tools like EPUB Check and ACE. There is MathCat, which I've already talked about. And then if you're writing scientific papers and publish them on the Internet Archive, then perhaps you're used to writing the math in LaTeX. And by all means, you can continue doing so, because Archive does an automatic conversion from LaTeX to the HTML format with MathML in it. But in order for this conversion to happen smoothly, there are some best practices that you need to follow. So do take a look at the Archive's recommendations for LaTeX markup. And if you intend to publish your article in HTML to begin with, but you're still used to writing your mathematics in LaTeX, you can continue doing so. And there are automatic conversion tools between LaTeX and MathML, for example, Pandoc or TemML. But I do recommend that you familiarize yourself with at least the basics of MathML. It's not too complicated, but just so you get a general idea of whether your intent really gets through. And then for image descriptions, there are discipline-specific guidelines for STEM image descriptions. For example, those by Diagram by Benetic. And now to answer the question of accessible STEM books, are we there yet? The answer is a resounding not really, I'm afraid. There still remain some further challenges before we're all the way there. Math is a verb. It's not enough to be able to write, to read math. You need to be able to write as well. And right now, there doesn't really exist a good, nifty solution for writing math in Braille. And that means solving equations, for example, gets very much of a challenge. And also, when it comes to images, sometimes an image description doesn't really do it, or maybe you have to be able to analyze your graphs and diagrams in real time and don't have time for someone to describe them for you. Then it could help if they're interactive so that you can move around in them and examine data points. Perhaps have them made accessible through sonification so you can listen to them. And then there's the case of computer code. We make a lot of books on programming, and the computer code in them, ironically, our computers are very bad at reading that aloud in an understandable way. So teaching our TTS voices how to read code is still a mission that we need to get on. And when it comes to application programming interfaces, for example, how accessible are they? And then there are probably tons of challenges that we haven't even thought of yet. But we're not giving up on this. Next year, in January, we're launching a tech review to get an overview of what STEM solutions exist out there. How accessible are they? And how compatible are they with one another? And the goal of this review will be to find recommendations for development projects that we could engage in or maybe inspire others to do, and also to compile up-to-date recommendations for our users on how to access STEM. And we need help to realize this vision of a society where all reading is accessible to everyone. So if you're keen to help out, there are a number of ways that you can do this. First of all, MathCat desperately needs future-proofing. As I mentioned, MathCat is developed by Neil Seufer, and he's basically doing this single-handedly, which means there's a lot of workload on him, and also it's very vulnerable. So if you're a programmer and want to help out to automate things and develop further functions, then please do get in touch with him. Seufer at alum.mit.edu. And if you happen to know of any accessible STEM solutions, then please do send them our way for the tech review. And my email is tim.arborealis@mtm.se. And last but not least, now you have had a crash course in how to make accessible STEM publications. So go ahead, lead the way, and spread the word. Thank you.
Thank you so much, Tim. That's some really great work that you're doing there. We can't wait for it to be in the market and all of us get to experience it. So if any of you have any questions for Tim, you can go ahead and ask them right now.
First, I would like to thank Tim. Me being a software developer myself and working on web for last 6 7 years, it's been an enlightening session for me because prior to today, like I didn't know that there is something MathCat existing over there because I was working on web development and I used to use some sort of accessibility using ARIA library and some text to speech stuff and like navigations with keyboard and all to make it more accessible for the users. But now today I go to know, okay, there is something like MathCat is existing there, and there is MathML which I've never heard of before. So thank you so much for like introducing us with such technologies. And definitely, like when you were talking about the like challenges that we have, for example, creating code for people who, like through Braille, or like how they can like solve the equations through like make it more accessible for them to solve the equations. So I was just thinking at that time, like now we have like large language models coming in, and we have like models where we can like speak to the computer in a natural language and try to like encapsulate in form of a code where we can read out the expression and computers might be able to write it. So so in that direction, what do you think, like is it a possible way of like approaching those solutions, or like where are we right now in those domains?
Oh, that's a very interesting question, because then we're talking not text to speech, but speech to text, if I understand you correctly.
Yeah,
Like,
yeah. I mean, for
like you.
people who are able to do that as well, like this is also some sort of accessibility where we are reaching some sort of solutions. So
Yeah, as far as my knowledge goes, right now, I am not aware of any like solutions for at least for advanced mathematics that do voice recognition in that way and actually get it into digital print. But it's for sure something that I will check out for the tech review, and I can get back to you in like half a year and give you a better
yeah,
reply, hopefully.
and
But it would be very handy to have,
yeah,
for
I
sure.
mean, this was something I was just thinking in air, like I just came up with some rough idea. If we can use the latest models that are existing, for
Uh-huh.
example, like training a model based on the previous data that we have for solving like complex problems, and
Mm-hmm.
like making the concepts more like in an understandable form. So for
Mm-hmm.
that, like we can have our own accessibility models like ChatGPT is there. So something like that we can build using like these kind of existing models on top of it. Like we can do something. So
Uh-huh.
so this is something I was curious to know about. Like if we have something existing already, or we can start working on it. Because as you mentioned that Sophia, the person who has built MathCat, like being in Boston, I'm not sure if he is also in Boston right now because he's MIT alumni, right? And where he's residing right now. But if this is
Uh-huh.
something like if he's here, like there can be an event organized by him or like a bunch of people like who can
Uh-huh.
volunteer and like spread the word with that, like how other
Mm.
technologies can also be a part of it, and like we can work on something collaboratively to achieve some sort of goals in that direction. So that'll be really helpful. So I'll try to contact him with the email that you have provided. Hopefully, like if I'm able to contribute something with my skill set, I'll be definitely be up for that.
That would be so great. I'm sure Neil will be thrilled to hear from you.
Yeah.
I think he's based on the West Coast, if I'm not mistaken. Uh,
Okay.
but I mean, he's really good to work with, and I think he travels occasionally, so I'm sure you could
Mhm.
set something up. And
Yeah,
we've
yeah,
had a
definitely.
lot of meetings like this remotely, so I'm sure he'd be all ears.
Yeah,
Well,
because
thank you.
just few days back, I was just reading about accessibility because I had call with some company regarding accessibility engineer. Now I have
Uh-huh.
something new to work on and like to tell them like, okay, this is something I have explored and
Hmm.
we can work on it. So that is really great. Thank you so much
Hmm.
for all these things to bring up all these things. I mean, it's really enlightening. Thank you so much, Tim.
Well, thank you for your enthusiasm. This is great to hear.
Thank you, Tim, for answering that question. And I had a question before we wrap up. So, when I was doing a little bit of research on you, I just saw that you were interested in a lot of things like storytelling, poetry,
Hmm.
and astrophysics. Am I right?
Uh-huh. Yeah.
Yeah. So how did this interest in accessible media come up out of everything that you do?
Well, it's a bit of a funny story, in fact. Um, when I studied at the university, to be honest, I got a bit burnt out from it, and had to like leave the field and do something entirely different for a while, working just with something physical as a janitor. But then I was in an accident and broke my arm and couldn't do that anymore. So I was looking for a desk job, basically. And then my bonus kid, in fact, 11 years old, had access to these talking books because they have dyslexia, but reading is their favorite thing to do in the world. And so they were like, why can't you start reading in talking books? It would be so great to get to listen to you. And so I applied. No, I started looking for how does this work, this service that my kid had access to. And it turned out to be this governmental agency. And in Sweden, you can't really spontaneously apply for a job at a governmental agency. That's not really how it works. But I held an open eye their way. And just a few weeks later, there came out an ad that said they're looking for someone who knows physics and maths. And that's what I do. So I applied for the job. And that's how I got into accessible book production because they wanted to hire me. So I basically knew nothing about accessibility until I started working at MTM almost 3 years ago now. So it's been very eye-opening for me to get to become aware of the challenges that uh, STEM students with disabilities face, because I struggled a lot at my time as a student while not having these types of difficulties. And so it feels like an honor for me to be able to help someone else do that in a way that makes it easier for them.
And that's some phenomenal work that you're doing there.
Oh, thank you.
So with this, we can. Is there anyone who has any other question for Tim, or we can go ahead and wrap up our event?
Can I just ask a question to everyone here?
Yeah.
I'm just curious if anyone here has some experience of like encountering difficulties while reading STEM books, either because of a disability or something else that you would like to share with me that I could take with me in my work.
I don't think so.
All right.
Not exactly.
Tim, I have not had any challenges, but I work in the Office for Diversity, Equity, and Inclusion. So I've just learned a lot today to be able to share, be aware of. And I think this matters for the work that we do. Just you don't know what you don't know, right? So this has been helpful. I haven't had that, but I'd like to share for more awareness. Don't know if I answered your question.
Yeah, thank you very much. That's great to hear.
I'm curious, now we have like assistive technologies coming in for people to read like mathematical equations and everything. But prior to that, how I was just wondering how people used to read that, maybe using Braille or like with the sign language, or like how. So I was not sure of it. How difficult was it for them to read in that way all the mathematical equations and everything? So it's like now we have technologies coming in, so it's better to deep dive into them. Like if we can come up with some good solutions for
Mm-hmm.
them. So I think after this session, my interest into getting into these things is like I'm gonna deep dive into all these things and learn more about it,
Mm.
and if we can like come up with something to
Mm.
make open source for people. So yeah,
Mm.
this is gonna be really great.
Yeah, I love that you're mentioning open source, so it will be accessible to everyone.
Yeah.
Maybe I can tell you a bit about like the situation in Sweden at least. I'm not too familiar with the situation in the US on how mathematics is dealt with up until now. But in Sweden, if you're a Braille user, then it's a bit complicated how you have to learn to read math, because we have one system for mathematics in printed Braille, and then some have to learn to read it also in other ways, using a system called ASCII math, where you basically write out the math in a text string. Like, for example, instead of visually having a square root, you would write SQRT and so on. And then you could have math in Word that works so for the input. And then, of course, you could have an assistant, like reading the math aloud to you and like writing down what you would dictate. And these are a lot of different ways that you have to learn and sometimes switch between. And of course, it would be inconvenient, especially for expressing yourself mathematically, because of course, when you do that, you want your teachers, your colleagues, your fellow students to be able to understand without like having to have an interpreter that everything goes through. And right now, that's the main challenge, that like you can't like participate directly on the same terms as everyone else.
Got it. Yeah.
I don't know
Thank
if
you,
that
Ted.
answered the question.
Yeah. I mean, it's I completely understood your point, and I was thinking in the same way, because like for some people, reading exact mathematical equation won't be feasible. So if there is a way where we can translate that equation into an English format or their native language format, where they can
Mm.
easily read it and express their thoughts on it. And
Mm.
similarly, like with my speech to text was also the same thing. Like if they could
Mm.
talk to the system in their native language with natural
Mm.
language processing, and we can convert into some sort of mathematical expression and like work on it. So that's
Mm.
what I was thinking. Like if we can prepare some model on top of it,
Mm.
and then make it open source for people to use it. So
For sure.
so this is something we can like work on, training the models and improving it by the time, and then
Mm.
like bringing up multilinguistic model as well for like different countries and regions, so that might also help. So I mean, it's
Yeah.
a very great area to explore and innovate
Mm.
in. So, I mean, it has like, on technical point of view, it has like very bright, like sidelines where
Mm.
like innovation is not like it has great heights to achieve for. So, I think, uh, I mean, getting into this will definitely get us with some exciting products as well for
Mm.
students like in coming time. So I mean
Right.
that
Yeah.
yeah.
Yeah. Thanks for sharing that. And I'd like to ask a question. Maybe I don't know if you can answer, Valerie, about the sign language of mathematics. Is there specific sign language for advanced mathematics?
So, not a math person, so I'm the wrong person to ask. But at the high school and college level, there are specific signs and linguistics that match the language of math. For the deep STEM math and high level courses, I'm not sure. I've interpreted for coding companies before who there were web developers in the room, and some of the staff members were deaf. And so I interpreted and I let them know, I am sorry, I don't know about coding. I'm not sure. And they said, just fingerspell everything. So for all the things that I didn't understand, I fingerspelled it and they were like, I get it. I know what you're talking about because I'm a coder. You may not have signed it right, but I understood it. So I'm not sure about the specific language of math when it gets to like higher than like basic college and high school levels.
All right. Thank you very much. I'm sorry for putting you on the spot like that.
But Valerie did a great job with the quadratic equations. I was looking at her whenever you said a squared and b squared. Yeah, thank you so much, Valerie.
Yes, thank you. Thank you.
So I think we are in the last 5 minutes of our schedule. And so let's wrap up by, first of all, thanking Tim. Tim, thank you so much for collaborating with us. That was a very detailed and a wonderful presentation with all the examples. I really like that you put in some examples of the model that you're going to create. And I'm looking forward to seeing this model in the market soon. So, yeah.
Well, thank you so much for inviting me here. It's been a pleasure to talk to you all. And thank you for the great work that you do with these talk series. It's really amazing.
Thank you so much. All thanks to the founder and the co-founder, Dr. Mohammed Kara and Dr. Sandra. And thank you to everyone who joined us today. We have our next event coming up on the 25th of October in the same room from 2 p.m. to 3 p.m. All our events are hybrid. And we have an assistant professor, Christine B. Monroe, coming, and she'll be talking about making STEM environment accessible for neurodivergent minds, something similar to this. Yeah. So I'm excited for the next event. Hopefully, we have all of you present in our next event too. So have a wonderful day. Thank you again, Tim. Valerie, thank you so much. You did a phenomenal job today.
Thank you all. Have a great weekend. Bye.
Happy weekend, guys.
Thank you everyone for being such a great audience. We hope you enjoyed Tim's insight on accessible STEM book production and the latest digital tools. We hope this discussion has sparked curiosity and commitment to fostering collaborative environments where every voice is heard and valued. Stay tuned for more enlightening content and don't forget to like, share, and subscribe. Until next time, this is Allied signing off. Thank you.